Welcome to the 118th episode of the Flipped Learning Network podcast. I'm your host, Troy Cockrum, along with my co-host, Joan Brown. Today we are talking with Dar-Wei Chen. Dar-Wei, can you tell us what it is that you do and sort of your role in education?
Yeah, so hello everyone, I'm Dar-Wei. I'm a third-year PhD student at Georgia Tech. I work in the Problem Solving and Educational Technology Lab under my advisor, Dr. Richard Catronbone. And in our lab, we do a lot of research into, obviously, technology in the name. So we do a lot with that and a lot about instructional design. So how do you design materials for students so that they learn more efficiently, learn better with less mental workload and that kind of thing.
And so what we wanted to bring Dar-Wei on for was he has done some research in using interactive multimedia and comparing it to passive multimedia and how that affects how students learn and gain information and things like that. Can you tell us a little bit about your research?
Yeah, so I recently presented a paper at the Human Factors and Ergonomics Society conference in October of last year, and this study that I did was about how interactive materials compared to more passive materials in terms of instructing students. And so in my study, what I did was I had participants learn how to solve a Rubik's Cube. And they were put into one of two conditions. The first condition was what I call the passive condition. And you can imagine a passive condition by thinking about what you would do when you watch a YouTube video. So when you watch a YouTube video, you click play, and generally you just let it go until you feel like stopping, but there's nothing that makes you stop anywhere, right? So it's kind of a passive sort of experience. Now, so that was the participants in one condition did that. Now, if in the other condition, the participants got to use what I call the interactive tutorial. And in the interactive tutorial, they got to use sort of like a Java applet, and basically they could control a few things about their experience. So one of the things that they could control is the pace at which the moves on the Rubik's Cube are demonstrated. So if you think about if you were watching a Rubik's Cube, there might be turning of the cube, and you might want to see moves more slowly depending on depending on the pace at which you learn. And so with the interactive one, you can control how quickly those moves come. You can scroll through the moves one by one. You can also rewind them one by one. And so you have that element of control. And then the other interactive element was that you could control the rotation of the cube on the screen. So if you need to see what's behind, on the other side of the cube, you might want to turn the cube on the screen so that you can see it. And so those were the two elements of interactivity. And so that's the two main differences basically between the interactive and the passive.
Can I ask you more specifically about the interactive Java? Each of the sections, they were actually video sections though that ran, or was it just a 3D model that would work you through?
Yeah, so the interactive tutorial wasn't really a video per se.
Okay.
Although there was an option for it to work pretty much like a video, so you could also press sort of like a play button and it would just run all the moves consecutively through. But it just had the interactive options of scrolling through the moves individually or rotating the cube so that you could see all the different sides of it.
Okay. Oh. So, I mean, if we'd use a little teacher speak, it's kind of like chunking it, or even providing think time, because whereas a video on YouTube is just a constant flow of information.
Right.
Teachers that are masters at teaching will use think time. They'll stop and they'll pause, and by putting that in there, almost purposefully, to pause, to stop something, even though some people think, oh, I don't need think time, a lot of students are they just want to move along, even they gain from that to some extent. So I kind of like the idea of having a job applet that you can, or you can avoid going straight through, that it actually would be stopped in certain places.
Yeah, definitely. I think the natural stopping points force people to at least consider whether they actually learned the information from before that stopping point. You know, and I think, yeah, because everyone likes to think that, oh yeah, I learned that, I don't need to. You can just keep on playing. It's like, I'm fine. But in reality, that might not be the case. So, that's one of the benefits of doing it this way. Definitely.
Did the sort of module tell you, like, were the students trying to solve the 3D puzzle and then it would tell them if they were correct or incorrect, or was it just showing the steps and allowing you to go back and forth through them?
Yeah, it wasn't that advanced where they could get feedback necessarily on their movements with the cube. Basically, I would give them a physical Rubik's Cube, so they would have it in their hands, and they would be looking at a tutorial that's on the screen. So they could follow along with their cube, but they wouldn't be able to get feedback necessarily. Although they really should be able to tell, just based on what they have in their hands, they should be able to look at it and say, oh, that doesn't really match, so I need to fix something. They should be able to tell that much.
Can I now go into your hypothesis? Because I think I read somewhere that you had a prediction of what you thought was going to happen in this experiment, and it wasn't exactly the same results. Can you kind of walk through that?
Yeah, the hypothesis basically for me was, and this kind of, I think, is in line with what a lot of people think, which is interactive materials are always better, right? Everyone always tries to say that, like in classrooms, we should always be more interactive, because interactive is almost synonymous with engaging to some people, So I thought, okay, the people that use the interactive tutorial will for sure perform better than the people who use the passive tutorial. And it turns out that the results were somewhat in that direction, but not quite. Right? So it turns out that the people who came into the experiment with low spatial ability, which is very relevant for solving the Rubik's Cube, the people of lower spatial ability were able to solve the cube better with the interactive materials than with the passive materials. So that part kind of is in line with the hypothesis. The people with higher spatial ability, it turns out the results were opposite. They actually didn't solve the cube quite as well with the interactive tutorial. So this kind of effect is called an interaction effect, right? So the effect of the tutorial type changes based on the people, their individual differences, in a sense. So depending on their spatial ability, the material has different kinds of effects.
So are we going to want to be very observant then with our students and test them to find out their spatial abilities, perhaps?
Yeah, I think surely if they are learning spatial tasks, I think this is, you definitely want to have this individual difference kind of information available. So, but this, this could also extend, not that I've done research on it, but I imagine that it could also extend to, other areas where people who aren't as skilled or don't have the natural ability in whatever area it is, maybe the interactive materials can help them, but then the people who do have the natural ability, maybe the interactivity isn't as helpful because they, they're able to compensate, so to speak, for the lack of interaction just by their own natural ability. And so this is actually a theory in education. It's called compensation, and it's the idea that people of higher ability, when you give them all this, this kind of newfangled interaction and all that kind of thing, it ends up not helping them very much because they already can visually or mentally kind of already do all that. So it ends up being more of a burden on them actually to have all the interactive things.
So if I were putting together a little class or flip class maybe on solving a Rubik's Cube, I probably want to provide both. I probably want to provide the passive video, and I want to provide the interactive 3D environment for whoever wants it, because I'm going to hit upon both learning styles.
Yeah, and you don't really know who is in your class necessarily, right? They might have all different kinds of abilities. We all know, students come in all shapes and sizes, right? So we have to account for which kinds of educational tactics work for which kids. And so it might be a good idea actually for whatever kinds of whatever you're teaching your students, kind of first gauge their individual differences. What kinds of existing abilities do they already have, and then you kind of tailor your materials towards those abilities or accounting for those abilities.
Yeah, absolutely.
What made you interested in studying this?
Studying the Rubik's Cube, or studying kind of interactivity in general?
Interactivity.
Okay, the interactivity. Well, it was, I've always read. I've always been interested in how to educate just better. There's a lot of different. Obviously, there's a lot of different ways to do it. But because of technology, now we have these kinds of interactive capabilities, and so I figured that that's probably a good place to start in modern education. And so I wanted to see, how do we make materials better for students, and especially, for flipped classrooms. A lot of students are going to be learning material on their own, more or less, and without much teacher guidance. So it's even more important in those situations to have materials that students can interact with on their own and gain all the information they need. And so I feel like it's a really important problem, and that's why I was really interested in solving it.
Have there been any companies that contacted you that are interested in you going further with this, or maybe they want to use your study?
There are some people that have contacted me, not companies necessarily, but other researchers have contacted me interested in basically how does this apply to whatever they're doing. And I'm perfectly happy to talk to anyone who wants to know more about not necessarily Rubik's Cubes, but just interactivity and multimedia kind of in general.
Because I see a lot of the textbook companies are investing a great deal of money to make their textbooks online interactive and even to some point individualized. And if there's a study out there that indicates that that's the way to go, they probably would like that study. I'm also thinking in terms of those types of environments that can learn from the behavior of the user. So if the user chooses to use interactivity all the way through and their scores seem to increase that way, that an environment could give them more of that, whereas one that chooses not to and their scores are well for that purpose, then it would give them more of the passive learning. I'm wondering if that would be something that would come about fairly soon in the future, to adapt to the student's type of learning.
Yeah, I could definitely imagine that. I think I think that so that's sort of like an adaptable kind of
Yeah.
materials. That's what
I
you're.
mean, they already have some of those, but I don't know how much they adapt to the learning style. They certainly adapt to the level that the student is at, and they move them along a certain sequence, a Khan Academy type thing. But do they adapt to the learning style? And that's something that maybe your study is showing.
Yeah. Yeah, a learning style. Well, so that might be a little bit different from
Might be vague
what I
using
did.
that
Yeah,
terminology, yeah.
yeah, because what I did, I was more looking at kind of like pre-existing abilities,
Mm-hmm.
kind of,
Mm-hmm.
and now learning style, because I was just thinking learning style might be a little bit difficult to gauge through a computer. Like
Mm-hmm.
if you have an online textbook and they try to assess what style you are, that might be a little bit difficult. But
Right.
learnabilities is something that can definitely be tested,
Mm-hmm.
just electronically, I think. So, but yeah, I mean, insofar as you can do an assessment of learning styles you know, through online mechanisms, yeah, I could see it being a
Sure.
benefit. Yeah,
Sure. It's pretty cool, actually.
yeah, yeah.
I know this wasn't part of your study, but what about like these immersive environments? And we just did a show a couple weeks ago about Google Cardboard and how they're making immersive environments much more accessible. Do you think what you have here can apply to something like that?
To immersive environments. So, so an immersive environment is by nature probably more interactive than most other environments. So yeah, it could definitely, I guess, like my research could inform the design of immersive environments. Now, I guess for immersive environments, that's probably like the most extreme end of interactive materials, right? Because it's like everything is interacting with you. Um, so I don't know how the effects of interactivity change. Maybe there's a certain like Goldilocks zone of interactivity, and then past that maybe it's not so good again, or it maybe there's that kind of thing. So I don't know whether that's the case, but we'll have to do research on that.
Mhm.
I think too a lot of people they're interactive, like Camtasia has some interactive features and Edpuzzle, and a lot of times the interactivity is just add a quiz or
Mhm.
add something where the students have to click to get the video to go along, and that is, I guess, technically interactivity. It's not necessarily the most engaging interactivity.
Yeah, in my view, I think that interactivity is most useful, at least so in my case, for the people of lower spatial ability. My hypothesis is that it was useful because they had to interact with it in a way that made them assess their understanding of the material, and they had to interact with it to gain the understanding of the material. Not necessarily, just clicking play doesn't. That's not really, like, you have to do that anyways just to watch it, right? So that's you don't have to do that necessarily, or at least you don't have to think about how you're understanding material to click play. But if for example, if you're thinking about, oh, I need to see this piece on the other side of the Rubik's cube, so I need to turn it, then you're thinking about how you understand it, and you apparently understood why you needed to see that other piece, and that's why you're turning it. Then that makes the interaction meaningful.
I know here, at least in the state of Virginia, that's where I am, our standardized testing is now including these types of test questions that have interactivity in them. Lots of drag and drop, lots of manipulating a graph, or, there have been all kinds of different types of test questions that they've worked through. And I'm wondering if that has any implication on whether or not a student is going to score well on that question, if they happen to be, either have that ability, spatial relations or not, whether it affects their ability to answer the question.
Yeah, that's
Yeah.
that's interesting. That I think uh, if the if it's just the mechanism of answering the question that is different, so like instead of filling out a piece of paper, you are like clicking a radio button on a website. I think that probably shouldn't have too much of an effect. Although there actually are studies about basically if you take a test on paper or take it on a screen, are there differences there? And some studies do show that there are some differences. But my guess is that the interactivity is it will make most of a difference, or it will make more of a difference if it's directly involved in the way that people understand the material. So not necessarily by just selecting an answer. That's not necessarily
that. Well, they're actually having them manipulate objects now, and drag and drop to like, okay, create a parallelogram from these pieces or whatever, and so it's quite interactive. And I've been curious, whether they have any kind of statistics on kids having difficulty with the interactivity, just alone. Whether it be understanding the concept, whether they know what a parallelogram is or not, is the interactivity sort of what you were talking about, the compensation effect. I've always been wondering if there was a little bit of an issue with that. Perhaps maybe there is, but kids are going to have to overcome.
Yeah, I mean, that could be, and this is a problem that we now, I guess, that we've sort of created for ourselves, because now we are, of course, technology has many, many benefits, but now this is a thing that we now have to consider, because as we move, not only learning but testing into computers, now we have to kind of think about this. So yeah, I'd be curious to see if that has an effect. I won't claim to know whether that would have an effect, but I'm certainly interested in that. Yeah.
Well, I always claimed that handwriting on paper also gave a burden to the people that had poor handwriting and wrote slowly. So when they were taking essay exams, that was harder for them, and that was, going to cause a lower score. So I think it's the same situation when you're using any kind of computer interactivity. It's going to be the same. Certain people are going to benefit, and some, a few, may not.
Yeah. Oh, yeah. Definitely. I remember when I took the GRE. That was the first time that I took a standardized test on a computer, and I realized that there might be some people who didn't have a lot of opportunities to use computers,
right?
Growing up, like that's possible, and then so just the testing environment itself becomes a hurdle for them, whereas for me and for a lot of other students, the computer's just second nature. So yeah, it could definitely provide some benefit to some people, and not for others.
So where are you thinking about going, or where would you like to go with this in the future? What are you developing more study, or are you taking a different direction?
Yeah, so this study, it has, as any study does, it has its limitations. So one of them is that interactivity is not limited to just the things that I implemented in this tutorial. Like I have the interactive features where they can scroll through the moves individually and they can rotate the cube, but there might be other ways for tutorials to be interactive, and so it might be the case that only particular kinds of interactive features benefit people with low spatial ability, and maybe other kinds of features benefit people of high ability. That might be something that we find out. I'm also planning on. I am doing a follow-up study sometime soon. I'll probably get to it sometime in the summer, where I want to increase the difficulty of the task. So I had them solve I didn't have them solve the whole Rubik's Cube because that would take too long to teach. I taught them how to solve just a small part of it. It's called the cross. Basically, it's just lining up colors in a T, and so I want to, because in my study there was actually a little bit of a ceiling effect, with basically, I'm at Georgia Tech, and the kids at Georgia Tech are smart, and they figured out how to do the cross relatively quickly, more quickly than I thought they would. So quite a few of them were able to get all the way through and max out their score. And so I want to try to introduce a harder task, and when we do that, we'll get out more of a dispersion in scores, and then we'll be able to see, maybe it turns out that the task difficulty is also a factor in how interactivity works. So yeah, it'll be interesting to see what happens with that.
I'd be kind of interested too to see how many people wanted to go outside of the learning environment that was set up for them, and wanted to naturally find a different way if the way that they were doing wasn't working for them.
You're saying for like if they felt like the tutorial that they were using didn't really help them?
Right.
Well, I guess for this study, I guess they didn't really have a choice. So I wasn't going to let them. They can't
Right, I understand.
They can't jump to the other condition,
Right.
So, but yeah, I mean, I know that some of them, they got it so fast that they started to just mess around with the Rubik's Cube on their own. They weren't even doing what I told them to do. They were already done, and so they just started, doing their own thing. Yeah, I think the tutorial doesn't necessarily restrict them in terms of, like, you have to do only this. If they wanted to, they could look at it just kind of as a guidance, and then they can still try to figure things out on their own. It's just there for basically, as if you want to use this, you can. For Rubik's Cube, it's kind of hard to do it any other way, because I don't think most people can't intuit their way how to do it. So they kind of just need to look at the instructions. But for a few really smart kids, yeah, maybe they can find another way. But
so I guess they couldn't raise their hand and say, "Hey, can you help me over here? I don't understand this," right?
Or can I search for
Right.
for another
Right.
YouTube video
That's right.
if this one's not working?
No, yeah, they were not able to do that. That would definitely introduce some confounding variables into the experiment. So, yeah.
Well,
Why the classroom can't be an experimental place.
I had a student for his 20% project. He learned how to solve 13 different types of Rubik's. They're not all cubes, so I guess they're just Rubik's puzzles. But he learned to solve. He memorized the logarithm or whatever to solve 13 different kinds, and he could do them all within just like a few minutes. So.
Wow, I have a friend that can do a few of them. So the standard one is 3x3x3, and I have a friend that can do 4x4x4 and 5x5x5, and yeah, that already amazes me. But I know that there's also other ones that aren't even cute; they're just weird shapes, and that amazes me that people will.
That is impressive.
Yeah.
So, can you tell the listeners kind of where they can find out more about you and what you're doing? And I know you're on Twitter because we've talked through Twitter. Where can they find out more about what you're doing, and if they want to ask questions or contribute or anything? Yeah.
So the lab that I'm working in is Problem Solving and Educational Technology. So that's abbreviated PSET. And I imagine if you search for that and in conjunction with Georgia Tech, you'll be able to find our webpage. And on there, I have, so I keep my page the most updated out of anyone in the lab, so I'm proud to say that. And so I have I think 3 papers up there that you can look at if you want, and some various media coverage kinds of things, and also there are other people in the lab also that do a lot of things related to education. Of course, we're the educational technology lab, so we have people working on, one of my friends, Lauren, she works on defining, kind of defining the space of education, as in, what makes a flipped classroom, what makes a blended classroom, what makes a hybrid or a mixed classroom, what do all those terms mean? She's done a lot of work trying to define those terms and really making sure people know the difference between them. She also works on this concept called subgoal labeling, which is really interesting. And subgoal labeling is basically how do you break down a procedure into sensible steps so that people can basically learn in a more effective way. So how do you break it down into meaningful steps as opposed to just arbitrary step 1, step 2, step 3? How do you label them so that people can get like larger ideas and larger chunks of ideas out of each step? And so there's a lot of different ways to do that, and so that's what Lauren does. It's really interesting work. We also have, yeah, Lauren's great. We also have someone named Laura working on basically how do you present things, like what order do you present things in. So for example, you're working on a chemistry problem, and there might be someone who gives the worked example first. So worked example meaning just a practice problem with everything filled out, it kind of shows you how to do the example, and then tells you about the general theory of how you do the problem. Well, what if you do it the other way around? You have the general theory and then the worked example, right? Maybe one method is more effective than the other. And so Laura is working on that right now. And we have the other person in the lab, her name's Angela. Angela is working on basically how can we use the concept or this idea of interest to make learning material effective. So interest meaning if you provide people with, it's called seductive details in the parlance, I guess. And seductive details meaning things that are kind of inherently interesting, a little more sexy, so to speak. And so how do you use those kinds of details to draw interest into the material and engage people? And there's a lot of discussion in the literature as to whether those kinds of details help people engage more or whether they actually end up distracting people. So there's a lot of debate in the literature about that, and Angela is trying to basically clear that up a little bit and try to figure out whether it's a good thing to use these kinds of seductive details or not. So yeah, so we cover a lot of different things in the educational technology lab, and we're led by Dr. Richard Cantrabone, and he's our advisor.
It all sounds pretty interesting. Well, thank you for taking the time to talk with us. Our listeners are always looking for better ways to present their content that's going to be more effective for them. So I think your research kind of gives some direction on how they can kind of develop their own materials. So. Yeah,
definitely. And if they want to contact me or any of the other members of the PSET lab, there's contact information on our website. So yeah, they can do that, certainly.
Okay, well, thanks a lot for your time, and we'll be back again next week.
Thank you, Dar-Wei.
All right. Okay, thank you.